Section 6.2 and this video will also cover 6.3 and 6.4. By now, you should know all of the reciprocal identities, all of the ratio identities. You should know how all of the 6 trig functions relate to each other. And now we're going to cover these guys. And if you know these guys, then you can figure out everything else as far as trig identities goes just by knowing how they relate to each other, the 6 trig functions, and the sum and difference formulas. And on this video, we're going to learn how to derive all those other identities, plus using the Pythagorean identity. Okay, here we go. If you have the sine of the sum of two angles, and they're not common angles, or when you add them, they're not a common angle, then you can pull this thing apart by using this formula here. Notice that the first angle is called x in my little formula here. Second angle is called y. So the way this form works, sine goes first with that first angle, then it's cosine of the other, then you add, because you're adding here, then the cosine of the first angle, sine of the second angle. So all of these are the format of them is all based on what's the first angle and what's the second angle. Notice that the sign of the sum and the sign of the difference are very similar. The only difference is the actual SIGN in the middle. So it's sine, cosine, cosine, sine. If you're adding, then you're adding, okay? Sine, cosine, cosine, sine. If you're subtracting, then you subtract. All right, cosine is a little different. Sine always comes first when you're dealing with sine, but when you're dealing with cosine, the cosines are together and the sines are together. And notice that for cosine, if this is addition, then this is subtraction. If this is subtraction, then this is addition. Understanding the format of them will help you be able to remember the actual formula. Okay, now let's use these formulas to do some problems. First problem, if I have the sine of 15 degrees, I can break 15 degrees down into 45 minus 30, which gives me two common angles. Now when I'm using the sine of the sum or difference, it's always the sine of the first angle, cosine of the second. If that's subtraction, then that's subtraction. Then cosine of the first, sine of the second. Now these are values that we should know by now. If you don't know them right off the bat, then I recommend you use your cheater circle. Remember, if you know quadrant 1, you know them all. You know what? If you know quadrant 1, you know them all. So let's do just quadrant 1 here. So here's my unit circle. There's the 45, there's the 30, there's the 60, there's the cosine, there's the cosine, and there's the cosine, and the sines are on the y-axis. Okay, so sine of 45, always root 2 over 2. That one's easy. Cosine of 45 is also root 2 over 2. Cosine of 30, the 30-degree angle here, the cosine is almost 1. That's the big one. So it's root 3 over 2. And the sine is 1/2. Notice the 30-degree, the y value is about halfway. Okay? You just multiply this stuff out. Everybody's over 4. Multiplying straight across, root 6 minus root 2. If you wanted to keep a root 2 factored out, that would be okay as well. These are exact values. We're not going to stick them in the calculator. Tell you the truth, we don't use these formulas very much for actually finding the value of the sine or cosine. That was the sine of 15 degrees. Okay, if you get a problem like this on the test, I will have already taken this angle and split it up for you. You will see what you have to do. Your job is to remember the formulas. All right, cosine of the sum is cosine cosine, and then the sum becomes subtraction, sine sine. These are common angles. Cosine of a 30 is root 3 over 2. Cosine of a 45 is root 2 over 2. Minus sine of a 30 is 1/2. And I wrote down the wrong angle here. Sorry. That was a 4. Root 2 over 2 for the 45s. Multiply it out. Root 6 over 2, 4 over 4 minus root 2. So almost the same as the last one. The only difference is, okay, they're exactly the same. That's okay, because if I take this angle and I add it to this angle, this is pi over 12, I get pi over 2. So these angles add to 45, so the sine and the cosine, they're complementary, in other words, so the sine and cosine just trade places. I didn't expect that to happen. That was pretty cool. But there you go. Okay, we learned these cofunction identities early on, where the sine and the cosine, because they're cofunctions of each other, they're just the opposite angle of whatever angle x is. You flip the adjacent and the opposite, and you get the cofunction when you have 90 minus. But let's prove this. Cosine of the difference is cosine cosine plus sine sine. Remember, with the cosines, you change the SIGN. If this is subtraction with a cosine, it changes to addition. Sine stays the same. Okay, cosine of pi over 2 is 0. Sine of pi over 2 is 1. And I have proven the cofunction identity using the sum and difference formula. Let's go the other way. If I have sine, it's sine goes first, then he lets the cosine go, and he keeps the SIGN, then he go, cosine goes first, and then the sine. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. And I get plain old cosine x. Booyah. So, again, we verified these identities by using the sum and difference formulas. Okay, 6.3 is one of the most important sections in the whole chapter. 6.1, 6.3, and 6.5 are going to be the lifeblood of the whole chapter, and that's what the next test is going to be. You use the stuff from 6.2, the sum and difference formulas, to derive all the other identities, right? I can find the sine of the double angle by using the sine of the sum. 2x is just x plus x, right? So this is how you derive the double angle formula for sine. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. But because those angles are the same, and sine times cosine is the same as cosine times sine, I have 2 sine x cosine x, because those guys are the same. And that is the double angle formula for the sine. This is very important that you remember. Practice deriving it a couple of times for yourself, and you'll remember it. When you start solving equations, you're going to need to be able to change this angle sometimes because all your angles have to be the same, and the only way to change the angle is with an identity. So you need to remember, you may see this in a problem and be able to rewrite it like this, or you may see this in a problem and be able to rewrite it like that, to verify an identity or to solve an equation. Okay, cosine of 2x is the cosine of x plus x. Now the cosine of the double angle is way, way, way important because you get a whole bunch of other identities just from the different forms of the cosine of the double angle. So let's derive this thing. Cosine of x plus x is cosine of the first, cosine of the second, and then you change that sign to a minus before you write the sine of x and the sine of x. Now notice that this is cosine squared minus sine squared. This is the first form of the cosine of the double angle that we're going to look at. Notice that it looks a lot like the Pythagorean identity, but it is subtraction. If this was addition, then this would just equal 1. But because it's subtraction, you're actually getting the cosine of the double angle. Now we want to use this to derive more identities. Now we know the Pythagorean identity says sine squared plus cosine squared equals 1. That means that sine squared equals 1 minus cosine squared. Very important that you see these. Cosine squared is 1 minus sine squared. Keep all of the forms of all of the identities in mind when you're verifying or solving an equation. So in the next formulation of the cosine of the double, I can change, let's change cosine squared to be 1 minus sine squared and see what we get. I'm going to do this in green here. And this gives me the second formulation. All of them are important. I get 1 minus twice sine squared. Very important for you to remember this. If you derive it for yourself a few times, you're more likely to remember it. All of these identities are going to be heavily used when you get to Calc 2. It's a long time to remember them, but if you know how to derive them, you'll never forget, okay? So there's one more form that we have to remember, all right? I'm going back to blue here. From this equation right here, I'm going to replace the sine squared with 1 minus cosine squared. So I get, from the blue above, cosine squared minus parentheses 1 minus cosine squared. That's replacing the sine squared from above. Distributing the minus, and I get the third form, which is twice the cosine squared minus 1. Notice the forms of these three formulations of the cosine of the double angle. It's either that subtracting cosine squared minus sine squared, or there's a double sine squared but he's negative, or there's a double cosine and the one is negative. Do you see how these are a lot alike? And that's very useful. You may see this when you're solving an equation and you can change it, or you may see this when you're verifying an identity. Sometimes you're given this and you'll have to rewrite it like that. You could even factor this. This is the difference of two perfect squares. Maybe that'll help you verify an identity, something like that. Okay, now these two guys are what's important for what's coming next, which will be power reducing. Vital that you learn how to use power reducing, or half angle, which you don't see quite as often. And remember, a double angle or a half angle is just, it's all about how you look at it, right? So here we go. All right, first off, we have this form of the double angle for the cosine. Power reducing formula is used in Calc 2 a lot when you're doing something called an integral. And if you're integrating a cosine squared or a sine squared, there's nothing you can do to it. So you have to have something else to replace cosine squared or sine squared with. That, and using these two identities will reduce that power so that you can have the sum of lower power stuff here. So all I'm going to do, and it's very simple, all I'm going to do is isolate the cosine squared. So I'm going to add 1 to both sides. Cosine of the double angle plus 1 equals 2 cosine squared. And so I see that I can take cosine squared of x and I can replace that with 1/2 plus 1/2 cosine of the double angle. This is very, very, very important when you get to Calc 2. All right? And you've got all the tools to derive this stuff for yourself. So there will be times when you have to get rid of the square and rewrite your problem in a way that you can solve. And it's 1/2 plus 1/2 cosine of the double. Now when we're doing it with the sine squared form, say I'm given sine squared in my problem and I need to get that power away from there. So let's solve this. I'm going to cheat a little bit. Because this is negative, I'm going to move him over here and move the cosine over there. That's going to give me 2 sine squared equals 1 minus cosine of the double. And now I divide both sides by 2, and I get 1/2 minus 1/2 cosine of the double angle. Look at these two power reducing formulas. They look almost exactly the same. It's all about the cosine of the double, right? But when you have a cosine squared, it's a plus. When you have a sine squared, it's a minus. And if you can remember the format of it, then you can remember the formula of it, okay? Now, let's look at both of these formulas so that we can derive our half angles. First off, look at this right here. If I take the square root of this, I get just the cosine. It's going to give me plus or minus the square root of this thing over here, okay? And notice the relationship between the two angles. If this is x, this is double x. But if this was just, for instance, theta, then this would be half of theta, right? So this is half of that, and that's where I come up with my half angle formulas. So for the cosine of half the angle, notice what I'm doing here, I'm going to get the square root of 1 plus cosine of the angle over 2. Notice that I just wrote that as a single fraction because the denominator was the same, and I just took the square root of both sides, and I was focused on the relationship between the two angles, right? This one is half of this one, so I just changed their names, okay? because it's all about the relationship. Okay, now you need to remember from all of your algebra and pre-calculus classes that anytime you take the square root of something, you have to say plus or minus, right? So don't forget that still got a job to do. You have to figure out whatever this angle was, what quadrant is half of that angle going to be? And that'll tell you whether the cosine is positive or negative, okay? So it could be either one. Do the same thing for the sine of theta over 2. Notice it's about the relationship between this angle, well, sorry, down here, between this angle and this angle. This is half of this, and I'm just going to take the square root of both sides of those equations and rewrite the relationship between those angles. We had a common denominator. It was 1 minus cosine of that angle, okay? These are not used very much, but you could use them. Okay, one more tool that you may need when you get to Calc 2 is called power to sum. It's not as useful as power reducing. You're going to do that a lot. But there may be a time when you have a sine and a cosine, or two sines or two cosines multiplying each other, but they have different angles, and you need an identity to be able to work with that. All right, to do product to sum, you need to know all of your sum and difference formulas. Here I've written down the sign of the sum and the sign of the difference. Now, what happens when I add these two things together? Well, this is the same as, so that's going to give you 2 of those guys. So I'm going to get 2 sine x cosine y. This is not a double angle because your angles are different. You've got to keep that in mind. When I combine these, they go away. That equals 0. So I have a product to sum formula. So I'm going to take what I just found, I'm going to lose the 2 and put it on the other side, because the point of this is that you have the product of a sine and a cosine that have different angles, okay? So if that's the case, you use these two formulas, you add them together, and I'm going to lose the 2 by, this is what you want to replace, right? So divide both sides by 2, and you have 1/2 sine of the sum plus sine of the difference. You cannot separate the sine from what you're taking the sine of, okay? So we can't mess with this. The only way we could mess with it is to use these identities, and we'd end up with just sine x cosine y equals sine x cosine y. All right? Okay, so anytime you have the combination of sine and cosine multiplying each other, you can turn that into a sum. Next, if you have 2 cosines or 2 sines, here, if we subtract the cosine of the sum, or the difference, sorry, the cosine of the difference minus the cosine of the sum, look at what happens. The cosine subtracts away, and we're going to get sine x sine y, a product of 2 sines, minus the negative is going to give us 2 of these, right? So we're going to get 2 sine of one of the angles, sine of the other angle. So for this problem, we have subtracted these guys and gotten 2 of the sine times the sine. So anytime I need to replace the product of the sines of 2 different angles, I can get the difference of the cosine of the difference and the cosine of the sum. I don't have these memorized. They're not used very often. I didn't say that out loud, but I can sure enough grab a piece of scratch paper and derive it when I need it. So pay attention to whether you have a mixture of sine and cosine with different angles multiplying. That's the one we did first. This is a mixture of a sine times a sine with different angles. And then lastly, we have the one below. This one, when I have the difference and the sum and I'm adding, the signs are going to subtract away and I'm going to get twice cosine cosine. So when I do this one, I get twice cosine of one, cosine of the other, and now that is equal to the sum of these cosine formulas. So I'm going to get, moving that thing I solved for, cosine x times the cosine of a different angle is going to be 1/2, and now I'm adding the cosine of x minus to the cosine of x plus. And that gives me a product being reduced to a sum. Now this is just an angle and this is just an angle. They're being separated by addition. So when I get to calculus, I can do whatever process I need to do more simply to a simple cosine and a simple cosine being added together than I could if they were being multiplied. So when it comes down to it, you may need to use these, but not until Calc 2. So best is for you to memorize, at least very closely, at least the formatting of the sine of the sum and the difference and the cosine of the sum and the difference so that you can derive all of those other angles that we've talked about in this video. Okay, let's put some of these identities into practice. Okay, I want to verify this identity here. So I'm going to, first I'm going to move this other guy down a little. I want to pick a side, right? Well, this is very simple. This would be 1 minus 2 sine cosine. There's more going on this side, so I'm going to FOIL that out. I'm going to pick the left-hand side. I'm going to stick with it. Squaring the blob means multiplying it out. Sine times sine. Minus sine cosine is minus 2 sine cosine. Look at that. I'm almost there. And the last times the last is minus times a minus. Cosine times a cosine. Look what I've got right here. I have sine squared plus cosine squared, which equals 1. And 2 sine x, cosine x, that's a double angle formula for the sine. 1 minus the sine of the double angle. Now I knew I was going to need to find that because in the original problem I had a different angle, all right? So pay attention to what you're looking for. Be fearless and creative, right? Next one, notice how on both sides I have double angles, right? This has 3 forms, and I don't know what form I want, okay? I can't change this to cosine over sine and leave this and then multiply them because the angles are different. You always have to get the same angles, okay? So I'm going to start over here. There's subtraction. It probably doesn't matter which side I start with because I just have to do something, right? Okay, sine of the double is 2 sine cosine minus cotangent is cosine over sine. Now you see I have a fraction so I can get a common denominator. The other side was multiplication. It wouldn't have helped me. So the common denominator is going to be the sine. That means I multiply the first thing by another sine. So I'm going to get sine squared cosine x. Now I'm running out of room. Minus cosine x. Notice that I can factor out a cosine on the top, just to see what happens. 2 sine squared minus 1. Does that look familiar? Over sine x. Well, cosine over sine gives me a cotangent, so that part's done. Notice that I needed a cotangent, but this is cosine of the double. It looks like this, but it's supposed to be 1 minus. Well, looky there. There's a minus sign right there. So I'm going to, at this point right here, I'm going to pull out a minus sign here. It's the negative of 1 minus 2 sine squared. And now I'm going to take this minus sign, put it out front, and I'm going to rewrite this as the cosine of the double. And I get negative on the front, cotangent of x. 1 minus 2 sine squared is cosine of the double angle. And I'm done. Not so bad, right? That was about as complicated as you're going to get. If I had done this side, I would have had to choose which form to change this to. Would I use 2 cosine squared minus 1, 1 minus 2 cosine squared, or cosine squared minus sine squared? See, got to make a choice there. So this was easier because I had subtraction. This was a fraction. So I knew I could get a common denominator. Once I got that common denominator, there's not much you can do. So I just noticed that I had a common factor. Pull it out, see what's left. Fearless and creative, guys. Have fun with your homework.